Hello, this is Mr. Win, and this video is about similar polygons. So, congruent figures must be the same shape and same size. That means matching angles and matching side lengths. Similar figures only have to have the same shape and proportional sizes. So only matching angles, not necessarily same size side lengths. So here's an example. Notice these two shapes have four same angles. Well, all the sides are different, but they're proportional. So we have corresponding angles. Remember, order matters. So the first letter equals the first letter. A equals W. Second letter. B equals X. Third letter equals third letter. C equals Y. Fourth letter, D equals Z. So those are equal because they're congruent. Angles must be congruent. Then for the sides, those must be proportional to make a fraction. They're going to make the same ratio. So the first two, A to B, divided by W to X, the first two. That's why that's the first fraction. Is going to be the same thing as the second and third. B to C equals the second or over the second third. X to Y, that's the second fraction. That's the same thing as third and fourth, CD over third and fourth, YZ. And even fourth and first, or first and fourth, AD over first and fourth, WZ. All those we're going to turn into 3 over 1 when you reduce. Alright, so they must have the same scale factor, which I'll show you in the next slide. Alright, but like congruent statements, the order of the verse is very important since it identifies which angles and sides are corresponding, so I can write those equations or fractions. Oops. Alright, so I just mentioned scale factor. It's because if two figures are similar, then the ratio of two corresponding sides is also called the scale factor. This acts as a multiplier to make the original shape into a bigger or smaller new shape. It depends on which direction we're going, but the formula is usually K equals new over old. And sometimes we say SF, so scale factor equals new over old. So in this picture, triangle ABC is similar. So similar is this squiggly mark. There's no equal sign there. Is similar to triangle XYZ. The scale factor from triangle XYZ to ABC. So XYZ will call this the original, the old. And ABC, this is the new, is 6 over 3, which reduces to 2. So notice, let's see, they gave us XY is the first two, and AB is the first two, right? So they do correspond together. But with the new one, 6 over the old one, 3 is 2, so we got twice as big. But if we reverse that and change it the other direction, see, this is the old one, this is the new one. From ABC to XYZ, the new number is 3. The old number is 6. 3 over 6 is 1/2. It got half as big. And these are multipliers. Alright, the scale factor can be a fraction. That's going to be the case most of the time. And the entire shape must follow the same scale factor to be similar. You can't just triple a side and double another different side. The whole thing has to be tripled. The whole thing has to be quadrupled or halved or times 2 over 3. But you can't have multiple scale factors for the same picture. Alright, so when determining if two figures are similar, make sure the corresponding angles match and corresponding sides are proportional. All right, and here's some tips. The biggest side of one shape must correspond to the biggest side of the other shape, and the smallest side must correspond to the smallest side. So here we're going to check if the figures are similar. If so, we're going to write the similarity statement. So for this top problem, there's two rectangles. They show us 3 90-degree angles. The fourth angle is also 90, so they have matching angles. So they have corresponding angles that are matching? Yes. So matching angles. Matching angles is yes. But we also need to check corresponding sides. Alright, the biggest side goes the biggest side. So that 18 has to go with the 10. And let me write like this. I'll actually write the... Alright, so let's see how they went. They went that direction. So let's call this the old shape. Let's call this the new shape. Alright, N to Q looks like it's going with Z to W. That's supposed to equal N to Q, so Q to R over W to X. Alright, now usually I don't even set them equal. I actually just do each fraction separate, so let's check that out. NQ is 18. ZW is 10. Alright, if I reduce that 18 over 10, divide the top and bottom by 2, you get 9 over, what's that, 5. Okay? Anyways, let's see what QR over WX is. QR is 9. WX is 4. If I reduce that, I get... You can't even reduce that. This is 9 over 4. Is 9 over 5 the same as 9 over 4? No. So since the scale factors are different, we say this is not similar. But last video showed you how to verify this. If you wanted to, you could multiply both sides by, I'll just skip like this. If I multiply both sides by 10 and then multiply both sides by 4, I'm going to get, what is that? 90 equals 72. That's not even matching, so this verifies or proves that those fractions are not equal. Alright, so you could set two pairs together and see if they're equal. If not, just do one pair, find the scale factor, see if that matches the scale factor of the other pair. Again, it must have the same scale factor for the entire picture to be similar. So I was using the second factor right here. Alright, next problem. Check the triangles similar, so write the similarity statement. Alright, one, are the angles the same? 27, 117, 36, 27, 117, 36. Yeah, matching angles, good. Angles are matching. Now we gotta check all the sides. I'm just do one at a time. So let's see, for the 117 degrees, it goes to 12. I'll do like this, 12. I like pairing them. So the biggest number goes to the biggest number, right? And you know the biggest angle is across the biggest number. So 12 divided 6 is 2. All right, I'm going to try a different one. Let's see, the smallest angle is 27. That goes with 3. The smallest angle is 27. That goes with 6. All right, 6 over 3. That's also 2. And last one, 36-degree angle goes with this 4. 36-degree angle goes with this 8. 8 over 4 is 2. Look, all three of them has scale factor 2. So 12 over 6 equals 6 over 3 equals 8 over 4. They're all equal 2. Since they are corresponding, then yes, these are similar. So let's use red. Yes, similar. So our similar statement. So let's do the left triangle. Let's go A, B, C. Triangle ABC is similar. We have to match the order. A is the 117, so H is the 117. B is the 27, so F is the 27 degrees. C is the 36, so J is the 36. There you go. Alright, if given, so they tell us the shapes are similar and ask to find a missing side or value, simply set a proportion with two ratios and solve. And again, here's a tip. Pair things up and pick 2. Be consistent on how you write the ratio when solving. So if A, C, D, F is similar to V, W, Y, Z, find X and Y. So first, let's find the corresponding sides. I can mark that. So AC, so we're not talking about angles, but if we did, angle A equals angle V, angle C equals angle W, angle D equals angle Y, angle F equals angle Z, but we'll do sides. AC, the first two, is corresponding to the first two, W, VW. So here's AC. I'm going to underline this. VW, underline this. All right, the next one. CD is corresponding to WY. C to D is out here. WY is out here. All right, DF corresponds to YZ. DF is down here. YZ is down here. And the last one, AF, VZ. What should I have in a triangle? All right. Maybe I should make that bigger so you can see the numbers. All right, so I like doing shapes. I like pairing them up. So we're solving, so we're going to do 2 pairs. And I like putting shapes, so pick any 2 shapes. Just make sure you can't, you're solving one variable at a time. You can't have X and Y. So notice I'm going to do the green pair, 9 over 6. All right. I do the 9 over 6, then I'm going to do, let's do the blue pair. Since I chose 9 from the top picture, I'm going to do the top blue thing first, or the bottom. So when I say write the ratio carefully, I mean sometimes teachers like saying, oh, do pair over pair. They do, again, circle over circle equals square over square is what I did. Some teachers like saying, do it one shape at a time. They'll say circle over square for one shape equals circle over square for the next shape. No matter how you set it up, if you solve it correctly, you'll be good. If I solve this, multiply both sides by 10, I would get 90 over 6 equals X. That does reduce. 90 over 6 is 15. I found x. Alright, I need to find another one. Let's find y. Y is that triangle pair. So let's try that. Let's do triangle over triangle. I'll do the top shape first. So top triangle over bottom triangle equals, let's do circle over circle again. Top circle over bottom circle. I only have one unknown. Solve this, multiply both sides by a denominator. Let's multiply by 6. So that gives me 6 times 12, 60, 72, over 3y minus 1 equals 9. I'm going to multiply both sides by 3y minus 1. This gives me 72. I distribute over here. That's 27y minus 9. I'm going to add 9 both sides. That's 81 equals 27y. Divide by 27, I get 3 equals y. That's the answer. Found x and y. Alright, so when solving for something missing, you must use 2 pairs and to them equal and solve. Alright. So after finding x is 15, y is 3, let's plug them in and check the perimeter. Also remember, A, C, D, F is similar to W, V, W, Y, Z. Remember the 4 over 6 makes 2 over 3 reduce, 6 over 9 makes 2 over 3 reduce, 10 over 15 makes 2 over 3 reduce, 8 over 12 makes 2 over 3 reduce. The scale factor K is 2 over 3. Alright, if I do the perimeter, I'm adding all the numbers. For the top, I got 42. For the bottom, I get 28. If I do new over old, new perimeter over old perimeter, if I reduce, I get 2 over 3 as well. That's what's to happen. A lot of kids forget that the scale factor is a ratio that can be used for solving, and the perimeters also can be used as a pair because they're going to make a ratio and can be used for solving. Alright, so here's the complicated one. A, B, C, D, similar M, N, O, P, Q. Scale factor is 5 to 2. Find the perimeter of M, N, O, P, Q. Alright, so this is a pentagon, irregular pentagon, because it's 5 sides, 2, 4, 6, 5, yep. If you wanted to, the long way is to find every single side. I know this scale factor is 5 for the first one, 2 for the second. That's a pair. I could find this thing right here, x. If I wanted to, I could say, oh, 10 over x, that's my square pair, here's my circle pair. I could say 10 over x equals 5 over 2. I solve times 2, both sides. So 20 over x equals 5 times x both sides. So 20 equals 5x divided by 5. X equals 4. So I just found this side. This is 4. I don't want to do it for all the sides. Definitely not. That takes way too long. So I'm going to be smart and do perimeter pair. Alright, so remember the perimeter is a pair as well. If I find the perimeter for the left side, let's see, that is a 20 plus 30 plus 7 plus 13 plus 10. That's 50 plus 7 is 57 plus that is 70 plus 10 is 80. I know here P is 80. We're trying to find this. We're trying to find P is question mark. I can make a pair. I'll call my square pair. So circle over circle equals square over square. We'll call it x. Solve this one. It'll be a lot easier. Times x both sides. So that's 5x over 2 equals 80 times both sides by 2. That's 5x equals 160. Divide both sides by 5. 32. Alright, that's the perimeter of the second picture. Alright, so recap for similar frame. Once you know the similar, to find the scale factor, you get one pair and reduce. If you do not know the similar, you must check all the pairs and reduce to make sure they're the same scale factor. Alright, if you're trying to find something that's missing, get 2 pairs, set them equal, and solve. And remember, the scale factor can count as a pair, and the perimeter can count as a pair as well. Alright, thanks for watching. Ask any questions. See you soon. Thanks. Bye.